So, one of my favorite things in the world is when somebody says that something can't be done. It just makes me want to try to do it 1,000 times harder. Um, Shout out to Reddit user Big N, who recently developed or designed a really cool bolt design that lays flat on the print bed for 3D printing, but compiles as a full object. Let me show you. It's easier to show than to explain. So here's the bottom surface of my print. So if I can get it to focus. And as you can see, this is two parts, right? And because it's flat on the print bed, the grain direction is horizontal. Now, this is a zero point 0.6 by 0.6 millimeter joint here, and you can take it right off the bed and fold it like this, and it magically becomes a solid object as though it were printed in a vertical orientation, but with all the grain direction and grain strength going parallel with the bit shaft. Now, this still has a problem, obviously. How do you get these two sides to join together in the best possible way? Now, ideally, you'd have some kind of a complicated snapping structure with interlocking parts. However, you can't do that really because it's touching the bed surface, and you can only go up, you can't go down into the bed. One option that I initially considered was putting a slot that went all the way through the shaft and then creating a separate independent piece that would act as a joint and just male to male join those two female sides together. However, that has some drawbacks, especially weakening the shaft, which is the most important part. So, and then I had this like flash of inspiration. I was like, okay, what's the best possible way to do this where you gain the advantage of both the horizontal and vertical strength of the 3D printing grain direction? So basically, this is really simple, but I just printed a sleeve that's designed to fit around the top of this, just like that. So you get the horizontal grain direction strength for this direction of flexing, and then for twisting and torque, you get all of the strength of the internal core with its horizontal grain direction. So I feel like this is a really good compromise, and it brings these two sides together really nice and strong and solidly too, and they don't really shift too much, like not enough. I haven't actually tested this out, but I was so pleased with this innovation that I felt like I needed to release a video on it right away, and I got a lot of interest in the last two parts of this video in this series, so I thought this was worth posting. So basically, yeah, this is a 1/4 inch shaft that's designed for a standard US driver bit. And yeah, so I'm going to do some stress tests on this after I make a similar design for my wood screw, because I know everyone thinks that it's impossible to make a 3D printed PLA wood screw, and I will agree that it's incredibly hard, but I don't think it's impossible, and so I'm going to keep working away at this problem. This is a new bit interface design also, which I'm pretty proud of, which I kind of discovered accidentally on my Uno card case project, where basically it was the only interface that I could create that actually managed to bond symmetrically as a 1/4 module in a a 4-piece, fully symmetrical, hermaphroditic container design. So yeah, anyway, this turns out to be a lot cooler than I thought, and I'll show why that is in another video. But anyway, for now, I just wanted to get this out there because I think it's just a really, really cool hack and reversible. It's like how to innovate around the technical limitations of the medium, right, and create the structural strength that you want without having to really compromise in any significant way. It's possible. It just requires breakthroughs and a lot of brain power. So thanks, Big N, for your really cool solution that helped me crack this problem. As they say, standing on the shoulders of giants. Thanks for watching.